Hi everyone, my name is Marius. Today I'll be doing video 3 in a series of videos talking about the ABCs of securing the branch edge with a router. Like I said, this is video 3 and throughout this video I will be referring to video 1 and 2 or making suggestions that there's some configuration that was done. So from my point of view, if you're getting stuck with understanding and you haven't watched video 1 and 2, I highly implore you to maybe go back to those videos and watch those videos. Like I said previously, today's video is all about the zone-based firewall, and we have discussed in video 1 the general consensus, basically how access control lists stack up against the actual ASPF, right, packet filter firewall versus the actual the zone-based firewall. Alright, and we've already done those. This is video 1, that was video 2, and this is now video 3. But however, zone-based firewalling is quite a huge concept to understand. So what I'm going to do today is I'm going to actually talk about the concepts of zone-based firewalling, what it does. Then we basically will talk about how to use ASPF with the zone-based firewall, and then we'll talk about how to use an object policy. Yep. So what's important is that as we move forward, we're going to just show you how to enable the zone-based firewall, tell you about the different zones you get, why you get those zones. That'll be video 3. Yep. Then we're going to go into, just to show you a couple of things, then I'm going to go into some configuration examples in video 4 using ASPF, right? Even though I'll do some of that today, but I'm not going to focus on it. And in video 5, we will actually use the actual object policy. Now I'm pretty sure in video 5 there will be more videos around this concept, because this is quite a broad spectrum of information to share with you, and I want to try and keep the videos a little shorter if I can. Okay, so just as a preparation method, I'll be working on the VSRs today, the virtual services router today. And the reason for switching over from physical to the VSR is I actually had a couple of comments from some people asking if they could replicate this in the VSR, and I've decided to move over to VSR so it's easier for you to lab this. Right, I know not everybody has a couple of HPE routers lying around that you can just start up and actually work with. Right, so from that point of view, I've created some type of environments where we can actually work with them. Brilliant. Okay, so like I said, we want to talk about the zone-based firewall. Zone-based firewall. Now the one thing that I want to reiterate is, remember the difference between routing and security / firewall is the default behavior. The default behavior of a router is if it's in the routing table, it will route until I deny it. The default behavior of security, it will deny it until I actually create a permit statement somewhere. Right, so I really stand by this comment. A great routing engineer, the nature of the engineer is to get the packet there as quickly as possible, guarantee delivery, and make sure that there's a great path, alternative path for it to get there, and prove that point. Yep. Things like ping and so forth, and their management protocols and everything else. That's a great routing engineer. A great security engineer just absolutely denies everything by default. He will not give people access to anything, and his whole life revolves around the security policy. So there's a reason I'm saying security policy. If you have a very simple security policy, and I'm going to draw it over here. Right, so depending on the security policy, how more complex this gets, right, the more things you want to do inside your security policy. For instance, I'm going to permit everybody to get to the internet, and I'll permit everybody to get to 2 servers. That's it. I would rather that you use something called an access control list in the router. It's a very simple way to set it up, because from a control point of view, you don't need much control because you don't have many services, and as the complexity drives up, this is the complexity, right? you would want to maybe start looking at alternative things to use. Right, why I draw a little box there is because at this point I'll say the default behavior would be routing. At a certain point what you do is you switch over to a firewalling function. Now, like we said with ASPF, it's a great way of doing it. At this point, all permitted except for whatever we deny, right? Or we can even create deny statements and then permit whatever the case may be. But the default behavior of the router is to route. ASPF is if you actually have a router connected to the World Wide Web and maybe to an MPLS network and to an internal network. Yeah, so let's call it intra for now, right? Or LAN, whatever the case may be, network. ASPF works really well because what we do is we actually deny all traffic inbound with an access control list. And we create the ASPF portfolio over here, the port, right? And inside the ASPF, we'll say detect, right? So with ASPF, we'll say detect. TCP, UDP, remember this, and applications like FTP, and so forth. What this does, different to the actual access control list, is it still uses an access control list, but the access control list is to deny all IP traffic inbound. So if somebody tries to from there hack you and try and get into your network, the packet will be dropped. The only time traffic is permitted if somebody comes from the inside and goes through this network, and then access list over here, this one, will create a pinhole for one packet to come back in again to this device. Much more secure. Okay, so this detect would almost be like a pass. Because if you don't have a detect, TCP, UDP, FTP, any of that, if you don't have it, the default behavior is that if you try and ping through that interface, it just drops everything. Why? Deny, deny, deny. That's the difference. It really moves into a firewalling function. You can't ping anymore, you can't do any of that anymore. Okay, however, what we're saying is, well, yeah, that's great for this type of environment, but what if we had more? What if we actually had a router that had a DMZ environment with a server, you know, or multiple servers? We actually had the internet, World Wide Web. Yeah, we could have actually also had MPLS, right? And at some point we've got a couple of LANs, and this is the financial LAN, and this might be, let's say, the president's LAN, the boss's LAN, and this could be, let's say, your database, or whatever, you know, gets more complex. So what you want to start doing is say, well, I need more control, right? And that's where the ASPF is not necessarily great, because it's actually designed more to be around the World Wide Web environment, right? And because we only apply it to one interface, what we could do is we could start creating zones, and that's where the zone-based firewall comes in. Now, I've discussed this in quite a bit of detail. Now, a zone-based firewall, like I said, will deny everything. So by putting these interfaces into security zones, they stop working as a router. Done. How do we permit traffic in a zone-based firewall? Well, you use ASPF. That's one way of doing it. I can apply ASPF policies to the zone-based firewall as a zone pair. So I'll start creating different zone pairs. So from president to internet, I can have a president to MPLS, I can have a president to, let's say, my financial services or database, whatever. And I create multiple zones. And I can apply the ASPF. So I can have an ASPF policy between president and financial that says inspect or detect, all right, X amount of traffic and nothing else. So it will allow this president's area to connect to a specific type of service, and then vice versa, this guy would not be able to talk back to you again unless you create that route back or to initiate the packet. Okay, so the zone-based firewall gives you a lot of control, but it also comes with configuration complexity. Now, in the ASPF, we have a certain amount of detecting and non-detecting and so forth, and you've seen that, right, with a deny IP access control list. Yeah, so if you want to move up from there, right, and you have more control and it's a more complex environment, you could move into the zone-based firewall with an object policy. Now that's where we're going to end up in the final presentations. is how to use object policies with object groups and bind them together. I know 100% whatever you do in here, you most probably could simulate somehow. No, you couldn't simulate it there because you've got a static access control list. But with ASPF to a certain amount, you could do that, yeah, with some really complex access control lists. The whole idea is, as we move up the stack, you will see, if you've ever programmed before, instead of reprogramming something the whole time, we create classes. You've seen this in quality of service as well. Okay, so by creating classes, so financial would be a class, presidents would be a class, your whatever zone, your DMZ would be a class, right? Then you would actually bunch services together. That would be a class. So when I start to configure, it's quite easy for me to say, okay, I want to combine classes with services and then bind that to an actual environment. So if I have to go and change, like say financial, it's got an IP range, I could put another device in there, another router, and I have another 2 in there, and I could just add those 2 to the class, and that class will be affecting all the other devices if I've actually referenced it. Much faster way to keep control of your configurations. But you have to keep your wits about that. Okay. So what we are moving towards is just not a router with an access list, but we are now starting to move towards quite a fully fledged firewall. Yeah, when we move into object policies. And that's what I want to do today. So I'm going to prove a couple of these things today, I'm hoping. Right? And one of the things I want to prove is when you actually put an interface into an actual zone, security zone, the firewall kicks in, and you'll see suddenly the deny action coming in, playing a role. Right, so what we have for today, I'm just going to jump over, is we actually have an environment that's quite simple. It's not very complex. I'm using routers and I'm using ICMP and Telnet. Okay, so I'm going to start with a policy. Policy that I'm going to say, I want to permit traffic going from B going to A, right? A services type, Telnet and ICMP. Why am I doing this? Because I want people to be easily able to replicate this. I don't want people to sit there figuring out how they're going to start up servers to try and get HTTP working and security and everything else. I don't want to lose you in the complexity of setting up servers. So I'm going to use basic stuff like Telnet and ICMP to prove the concept. Okay, so what I have is I've got router A, I've got my zone-based firewall. This, by the way, is already set up. And I've got router B. That's connected over there and connected over here. I'm just going to quickly give my interfaces giga 1/0, giga 1/2. Sorry, that's not the right giga there. That was wrong. Okay, let's do it this way. Sorry about that. Giga 2/0 because I'm working on the VSRs now. Okay. Then also I've got giga 1/0 and giga 1/0. This is IP range 10.1.1.0 and this is 10.1.2.0. Right, I've got 2 others over here, which is 10.1.3.0, 10.1.4.0. That's created. Not going to draw it in right now. I don't want to complicate things. Okay, this is .1.1.100 and .100. So what I'm going to do right now is I'm going to ping from B to A and I'm going to ping from A to B and Telnet and vice versa. Good. So we just can show things are working. Let's quickly get that done. Make sure my connectivity is working. So that's going to be, I believe this will be router B. Yep. Let's see. And this should be router A. Let's quickly find a router firewall. There it is, zone-based firewall. Okay, so let's go from zone-based firewall and we see display interface brief. And what I have is for interfaces 10.1.1.1, 10.1.2.1. As you can see, I've configured there. Giga 30 is 10.1.3.1 and 10.1.4.1. From an A's point of view, display interface brief. Right now, I've got 10.1.100. And for B, I've got display interface brief. I can tell you I've got router C and D as well. I'm just going to open up everything at the moment. So, ping 10.1. Sorry about that. 10.1.1. dot 100. Okay, I can ping the other side. Can I telnet to him? Okay, telnet 10.1.1.100, and I can telnet to him. And if I do a question mark, very few commands. And the reason for that is if you do this display line at the moment, you'll see something's connected to it. Okay, if I can show you, there it is on VTY 0. So let's do this. Control C, display current configuration, part beginning with VTY. Okay, let's quickly look at that. VTY 04, I've got user role level 1. That's just to show you that I'm actually telnetting into it. So what we have is we can actually telnet to it, and we can ICMP to it as well. So what's the problem? Well, as everything else in life, you know, there's a bit of a catch here. Okay, so we also have another statement in here in our policy which most probably says deny everything else. Okay, like I said, easy enough to do this with access list. I don't want to do that right now. What I want to do is very quickly just prove to you by using ASPF, okay, just for this example, what the zone-based firewall will do. All right. So let's just Control C out of it. Right now, everything is working. So I'm going to start a ping -C 10.1.1.100. Okay, and that should be working. It's pinging this device now. So with the zone-based system, what we're going to say is you're going to have a security zone, and it's going to say name. But before we do this, I want to show you something. Remember that these routers are set up as distributed devices. Basically, it runs a multi-core processor. So it's a multi-core processing operating system as well. So if you did a display, right, security zone, right now it says there is none. If you do display ASPF, all, it says not configured. So there is no firewalling on here at the moment. Right, as soon as you do this, security zone, name, and let's call it for now trust, not case sensitive. Right, and you quit out of this and you did a display command. Right, suddenly there's quite a couple. From this point forward, you've now enabled the security functionality of this device and thus enabled that core to do security. Just so you know. Okay, so that runs in a different core. Okay, so from that point of view, as you can see, I now have a couple of them mentioned. I only created trust. But I don't know if you saw, I created trust with a lowercase t. So it's not case sensitive, number one. Number two, more important, there's 4 default zones that will be created. Local, trust, DMZ, and untrust. That should suffice in most cases. I can add interfaces to these 3. I cannot add interfaces to local. Local is for local purposes, which means I cannot change local. Let me prove it to you. Okay. Security zone, name, and we're going to say local. I go into local and I say import interface giga ether 1/0, and it says can't add any resources to the security zone local. Okay, so just so you can see, I can't mess around with local. For now, I don't think we should change anything because by default this is pretty cool. I've got a trust environment, I've got an untrust environment, and I've got a DMZ. Okay, so what I want to do is maybe we can just write it in here. So let's say we're going to call this the trust zone. Ooh, that's heavy. That's a very heavy mark. Okay, so let's call this the trust, and let's call this DMZ for now. Okay, so for that point of view, I'm going to add giga20 to trust, and I'm going to add giga10 to DMZ. Okay, and at some point we might have an untrust as well. But remembering that DMZ is an untrust zone, right, for trust. We want traffic to flow this direction and never from this guy in. Because if you had an internet connection over there and you got compromised to your DMZ, you don't want that device. That's why it's demilitarized zone. You don't want that device to then open up a hairpin into your local area network and through that then go into the MPLS network. Okay, so you don't trust traffic from A to B, you trust traffic from B to A. That's it. Brilliant. Okay, so everybody with me. Good. Is that ping still running? I believe so. Okay, so let's go into the Zone Based Firewall. How do I do this? Okay, so there's already some names in there. So I go to Security Zone, Name, and Trust. And I'm going to say Import, Interface, Giga, 2/0. Immediately what's just happened now, as you can see, right, it's now importing there. Can this guy still ping? Ping 10.1.2.100. No more pings. Okay, what's happened here is I've actually broken out of my telnet session. I wanted to show you, basically, that's what happens. Okay, so the ping is dead, and I ran the ping from itself, so I don't let anybody pick it up. Brilliant. But I wanted to show you the telnet session absolutely just dies. Okay, so if you try and ping it now, 10.1.1.100 won't work anymore. Right, as a matter of fact, nothing will work right now. Okay, ping 10 dot, sorry about that, 1.1, sorry, let's make it 3.100. I can't ping anything anymore. As a matter of fact, I can't even ping my own default gateway anymore, because that's a secure interface now. That's in firewall mode. Nothing works anymore until I put a permit statement in there, a detect. Okay, however, from A, I can still ping 10.1.3.100 and 4, because they haven't been put into a secure zone yet. They can still work. Okay, so let's quickly go and fix that, because that's incorrect. I said to deny everything else, yeah? Okay, so let's do this. This time we want to go to DMZ. Okay, now we're in DMZ and we're going to say import, I can just do this, import 1/0. This will not work anymore. Gone, finished. Okay, so that's actually a very good environment that we're in at the moment. Deny everything else, because that's not working. But very important, and I'm going to show you very quickly now, this is something about a DMZ. If you now go into, let's just do it this way, I'm going to put another trust in here. Remember that what's in trust at the moment, display this, there's already an interface in there. Sorry about that, it should be trust. Trustzone. Okay, I've got 2/0 in there already. So what if I did this? If I said import interface gigabit Ethernet 3/0 and 4/0. Those are my other two routers, by the way. It's these guys, it's D and C. Display interface brief. Do you think they can ping each other at the moment? They're all in trust. If I do a display this, 2, 3, and 4 are all in the same zone, which is trust. Okay, I can tell you the answer to that question, and the answer is an absolute no. 10.1.3.100 can't. And 4. What I've just done now is, please keep this in mind, is I said deny everything else. The default behavior, I keep on saying this, of a firewall is to deny. It's not going to make the assumption, oh, because they're all in the same trust zone, they like to see each other. No, 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 that's not how firewall works. Firewall says, I don't trust anything, even if they're in the same zone. Okay, so this is pretty cool, because I've just denied everything else, haven't I? Okay, so what I could do, just to show you, right, that this actually could work. So let's start a ping here. Ping -C 10.1.4.100. I'm now pinging between C and D. Right. At the moment it won't work. Remember, because it's, even though it's in the same in the same trust zone, the default behavior is that it just won't work. Okay, and if I say security zone, there was something else here called intrazone. Intrazone, between zones, yeah? Intrazone, So if they're all part of the trust, the default behavior right now, right, is to deny, and I want to change that to permit. Now it works. So they can ping each other. So anything inside, so even this guy over here should be able to ping 10.1.3.100 and 4.100. But we still cannot ping 1 because that's not the same zones, yeah? Everybody with me so far? Okay, so what I'm going to do is, because we said deny everything else, I'm actually going to undo this command. Okay, because we don't want traffic to flow by default. We real security, hardcore security experts here, man. There it is. Okay, so now it's stopped again. Doesn't work anymore. How cool is that? Be very careful. Once again, like I said, if you are configuring a live site, when you do these type of things, that you could inevitably stop traffic flows because of the firewalling functionality you've just switched on. Okay, very cool thing right now is that there's nothing flowing, okay, in this network. So how do I go and permit something? Well, like I said, there's object policies and there's an ASPF policy. Okay, what I want to show you is you can actually have an ASPF policy 1, right, and then you can detect TCP, right, itself, and we can also detect different things here, right, like we said before, detect a couple of things that we have available to us and so forth. So I'm going to say detect TCP, sorry about that, detect TCP, but there's something here that you don't see, which is telnet. Okay, and that's what I keep on saying. If you want more control, that's where we have to start moving into the actual object policies. For now, I can only say detect TCP, right? I can then somehow block traffic with access this, but then it becomes more complex to do it the other way. And that's what I want to show you with the object policy, because I can actually detect or permit pass telnet specific traffic. Okay, and that's where I said the more control you want, the higher up you've got to move the stack, and the stack beyond this is the object policies. But for now, this will work. Detect UDP and detect ICMP. If I don't do ICMP, I can't work. All right. Now that I've said, okay, I've created a policy, and inside that policy, I'm going to basically allow this type of traffic to pass one way. And I'll prove it to you. It will pass from B to A, because what we're going to do is, how do we apply it? Well, I can apply it to the interface. Interface gigabit 1/0 and outbound, yeah? Because I can say apply policy, sorry, ASPF policy, apply. ASPF policy, apply policy 1. I can do that, and outbound. And that would work. But then I would have to create an access list inbound as well. Or I could actually apply this policy to a zone pair. Now this is where the zone-based firewalling comes in. I have to now create a zone pair. Zone pair, and I have to give the zone pair a name, right? And which you'll see just now. Coming from a source, where is it going to come from? Well, it's going to come from trust, isn't it? Going to a destination of, what do we say? DMZ, am I correct? Yep, there it is, trust to DMZ. So going from trust to DMZ, this is not from DMZ to trust. Remember, routing, if I have one-way connectivity, I must probably have two-way connectivity. If I can ping the other side, he most probably can ping me. Security doesn't work this way. Okay, security only shows one direction. If you want from DMZ to trust, you have to set it up. So I've now done that, and I'm going to say ASPF apply policy 1. At the same time, I'm going to also apply a packet filter. If you've seen video 2, at this point I would have said apply packet filter 3000 inbound, but in this case I don't specify it because it's actually applying to a zone pair. So it's going to use access controllers 3000. Right now I don't have an access controllers 3000, so let's create access control advanced 3000, and I say rule 10 This time, permit IP. I know it sounds weird, permit. It changes to permit here. Okay, so what I'm saying is I want all traffic to be inspected. Right, and that should all be applied to the interfaces now. In this case, now let's see, ping 10.1.1.100. I can ping. If I check this now, display ASPF session, there's a session there, it'll time out just now in a couple of seconds, right? And effectively the session will be for a certain time period, it will be open there. I'm not going to wait for all this to happen. At the same time, I can also go telnet 10.1.1.100. There I'm on A, yeah? And I should see more sessions in here. Happy with it? Okay, so that's working. That's pretty cool. You can see there's my session 23. Okay, if I actually go and say Control K, break out of it, what you'll see is because it's TCP, the session will actually drop immediately. ICMP is not UDP, but it's more like UDP type traffic. So there's no fin packet there to actually kill the session. But with Telnet, it actually works pretty well because it's TCP, more controllable. Okay, so would I be able to tell it from A to B? Well, the answer should be no. 10.1.2.100. It says connected, but it's not allowing the packets because the zone-based firewall is just dropping packets. So this guy's waiting for a packet to come back. He keeps on pushing packets, waiting that something's going to happen. Nothing will happen. Okay, because this guy's dropping the packets. He could also won't be able to ping anybody. 10.1.2.100. So there's no ways he can get into the network. B, can I ever use Telnet to get out? It can also use, but right now it also uses the fact that it can actually go and connect to A as well. As a matter of fact, I think what I've done is I've now combined video 3 and 4. Okay, for that matter. So from that point of view, as you can see, I've actually used ASPF. I've used zone-based firewalling. I've now moved up from where we had ASPF because I can create multiple zones. The cool thing about this is that I could go into this environment, right? If I get to the right device, that's those guys over there, that's A, and let's see over here, what I should have is I should be able to telnet 10.1.1.100. Okay, A also works. Why? It's part of the same security zone, which is trust. Okay, so this is the advantage of the actual setting it up with different security zones. So when we get to object policies, that'll now be video 4, of course. But if we get to object policies, you'll see that I will give you even more control. I will show you how to telnet, how to use object policies and basically object groups within the policies itself, and how you can apply different policies to different zone pairs. Okay, so I hope you enjoyed this video, alright, but like I said, just to summarize everything else, this is to get more control. As you can see, we're now moving deeper into configuration, and when we get to the object policies, you'll see proper configuration where we're actually going to bind a lot of things together. We're going to be creating classes, okay, which we refer to as classes, but that will be object groups, and we can actually reuse the object groups, pretty much like we've started doing now in the zone-based firewalling. Okay, and thereby I want to thank you for your time. Once again, we've done video 3 and 4 in the same time. Right, I've done ASPF together with the actual zone-based firewall. Thank you very much, and I'll talk to you guys soon. Cheers, bye-bye.